Welcome everyone to another CP Top Call. This is call number 158. It's my pleasure to introduce Dana Goward. Dana is the president of the Resilient Navigation and Timing Foundation, a public benefit organization dedicated to protecting GPS and GNSS systems and ensuring their resilience for critical application worldwide. He brings a unique combination of operational and policy experience. Dana has served at sea as a ship's navigator, as a U.S. Coast Guard helicopter pilot, and as the Maritime Navigation Authority for United States. Thank you for your service, sir.
Yeah.
He also spent over a decade as a member of the U.S. Presidential National Space-Based Positioning, Navigation and Timing Advisory Board, where he helped shape national policy and GPS and timing infrastructure. In today's talk, Dana will address an important question. GPS, a single point of failure, exploring the growing dependence on GPS for timing and positioning, its vulnerability to interference, and the need for a more resilient approach to navigation and timing systems. Please join me welcoming Dana.
Well, thank you very much, Ahmed. It's a pleasure to be here with you all.
Likewise.
The RNT Foundation is a scientific and educational charity. And just so you know, as a matter of context, we chose that methodology so that we could have commercial entities as members and supporters, but the IRS prevents us from supporting their financial interests. So they support our mission, but we can't support their interest, and that gives us the ability to give kind of objective advice to policymakers and the public, at least as objective as we can. So let's just kick right off with something really interesting. So you can imagine that as a Coast Guard guy, that's a pretty difficult clip for me to show. Actually, I think it's kind of a little ironic, though. That was in 1997, a really good example of art predicting life. Who would have thought back in 1997 that we'd have situations very similar to that right now? So again, it's good to speak to you today. GPS is our primary source of positioning, navigation, and timing here in the United States. And it has been called by members of the President's National Security Council, not the current one, but the last one, a single point of failure for America. So what is positioning, navigation, and timing? And how does GPS work? Well, GPS satellites are essentially clocks connected to radio. Three clocks, actually, rubidium, or cesium, and they agree on a very precise time, and they transmit it. And all of the GPS satellites transmit their time signal, the same time signal, at exactly the same moment. And when they do that, it arrives at your receiver at slightly different moments because of the difference in distance between your receiver and each one of the satellites that's transmitting the time signal. And so through a miracle of microelectronics and mathematics, your cell phone or other device calculates where you are in four dimensions on the Earth. Sorry, three dimensions on the Earth. It also knows what time it is, obviously. So the challenge is that GPS is highly precise. It's freely available wherever you can see the sky. And because we wanted to make it America's gift to the world, we we published the signal specifications so that it could be easily adopted by clever engineers and technologists. And that ploy has been incredibly successful. The signal, especially the timing signal, has been adopted for pretty much every application and every technology that we use today. And the challenges, not necessarily, well, it's certainly a problem that the GPS signal is used everywhere. But it's especially a problem because not only does everything depend upon GPS, but as you know, everything depends on everything else. And so if you have problems with the time signal, there is a possibility of these problems and failures cascading through various infrastructures. So, as I mentioned, it's one of the vulnerabilities of the signal is it is incredibly weak signal. In fact, it's compared to a 10-watt light bulb shining on the Earth from the surface of the moon. It's a very, very, very weak. And as I mentioned just a moment ago, the specification for the signal has been published so people could adopt it, and that has both of those things have led to a number of threats. So the threat most people know about is what you all in the computer world would call denial, or we call jamming, and the the threats are to both the signals and also to the satellites, as you can see here. Signals are threatened by jamming and interference as well, and the satellites, of course, are threatened by any number of kinetic challenges, potential challenges that might have in space. Jamming has been identified as a significant problem for quite some time. In fact, this is a result of a study that the European Union did back from 2015 to 2019, I believe. And in the process of doing sampling around the European Union and in other locations, they identified over 450,000 signals that had the potential of interfering with GPS and other global navigation satellite systems. There are four, by the way. Um, as you can see, the signals are quite varied, but you know they also identified that about 10% of those signals were intentional disruption signals, and the other 90% were spurious noise from different mechanical processes and electrical equipment that just accidentally spilled over and could interfere with GPS. They also, as you can see here, they identified about 300 different families of intentional interference devices. Now, the kind of interference devices that we have seen vary from very small ones that people use as personal protective equipment, if you will, so that they're not being tracked by their spouse or their employer or their fleet management hardware, to more sophisticated systems that are used by transnational criminal organizations and nation states, I guess I should say, all the way to including the item in the upper right-hand corner, which is a nuclear-powered device that Russia had planned and may well have already deployed into space, which, as you can imagine, would be a real concern. We have seen GPS jamming all over the face of the globe, pretty much anywhere there is conflict. And in fact, we've seen it places where there hasn't been conflict as well, but certainly it's most prevalent in conflict areas such as in the Middle East and Ukraine. This happens to be in Northern Europe, and it was just after Poland activated a U.S. anti-missile system along its border with the Russian enclave of Kaliningrad. And Vladimir Putin got particularly angry and so decided that he would interfere with GPS signals across this whole area. Now, I have to mention that these uh, hexagons that you see represent reports from aircraft that have had their navigation signal degraded. Um, Not everyone within this area has been interfered with. Aircraft fly at, as you know, quite high altitudes, and so they're able to see the line of sight signals that are coming from the ground. The impact on the surface is much more constrained because of the shielding of the curvature of the Earth, buildings, and that sort of thing. But we still see ships and surface transportation, telecommunications upon occasion being impacted as a result of this activity. And here you go, you can see even broader uh, impacts going all the way down into to the Middle East. As you can imagine, that's happening there as well. We have seen this in the United States upon occasion. Um, some of it is intentional, some of it's unintentional. The impacts in the ports, for example, typically are the result of a truck driver not wanting to be tracked and bringing a GPS disruption device into a port. That has, upon occasion, halted crane operations, which depend upon GPS for the cranes to be able to know where they are and where the containers are. And we've seen other mysterious, unidentified impacts, such as the impact on the wireless provider, the kinds of things that some folks see around airports, and even individuals being impacted when their GPS devices uh, are are jammed or interfered with, which brings up a good point because interference is interference, of course, whether it's accidental or intentional. But something that not a lot of people appreciate is that the first stages of jamming can look like spoofing, which is intentional interference, hazardously misleading information where uh, false GPS information is transmitted and the receiver thinks it's someplace where it's not. So, what will happen is if there's just a straight jamming or interference signal that's not coherent, the receiver will start to wander off. It won't lose track initially, but it will start to wander off and cause the operator of the aircraft or the boat or the vehicle to think they're someplace that they're not. We actually saw a case of this in 2019 where a commercial aircraft nearly impacted a mountain as it was flying through the fog towards, I'm sorry, through the smoke and haze towards Sun Valley, Idaho. It was had unidentified GPS interference, and which had led it off track and was heading toward a mountain when unfortunately a sharp-eyed radar controller gave it vectors around to another and to avoid the disaster. The first intentional and identified spoofing incident we know of is in 2011 when a CIA drone that was operating in Afghanistan was spoofed by Iran and landed at one of their air bases. Some folks in the United States said, "Oh, it's not possible," but Iran had the drone. Excuse me. And then Professor Todd Humphreys at the University of Texas said, "Oh, it certainly is possible," and demonstrated in their football stadium how he could take over a small helicopter drone by sending it false GPS information. You may want to know, may wonder exactly how that works, and so let's take a look at this, see if we can make this go.
Off the southern coast of Italy in June 2013, a 65-meter superyacht and her crew were part of an unprecedented experiment led by the University of Texas at Austin that successfully coerced the vessel off course using a custom-made GPS spoofing device. 30 miles from land, the crew's sense of the ship's location is based entirely on civil GPS signals broadcast from orbiting satellites. A UT student, serving as the attacker, commands the spoofing device to transmit faint counterfeit signals towards the ship's antennas. The attacker increases the power of the spoofing signals until they are stronger than the satellite signals, gaining control of the ship's navigation system. The takeover is stealthy. No alarms are triggered. Once in control, the attacker initiates a 3-degree change to the ship's course. The ship's navigation system reports that the vessel is drifting slowly to the left. The false location is represented here by the ghost ship. The crew applies a course correction to bring the ghost ship back onto the intended path. In reality, the ship is now on the attacker's course.
And so it's been quite a while since this capability has been democratized, and it's not only the province of national governments or academics. This gal at the DEF CON convention in 2015 brought a whole presentation about how to build one, and she even was selling parts so you could build your own hacker, your own spoofing device. Very shortly after that, the Department of Homeland Security said they're having problems with drones being spoofed by drug cartels. That was Public statement was later withdrawn, but we do know that the southern border has continued to have challenges with GPS spoofing and jamming. Another incident that occurred, you may recall, where two Navy boats were seized by Iran back in 2016. They were supposed to go from Kuwait down to Bahrain. As you can see, the little blue line there, it fairly straight down the coast course, but somehow they ended up approaching an Iranian naval base in Iranian waters. And so, um, was this a case of their GPS being spoofed? Well, there's a lot of evidence we think that it was, although the U.S. Navy said no, it was just a navigational error. But it is ironic that it was on the right after President Obama concluded a nuclear agreement with Iran. A lot of hardliners in that country were upset, and it was the same day as his last State of the Union speech. So we think that was probably spoofing.
By the way, Dana, sorry to interrupt. Are you okay to take questions in line in the presentation?
Oh yeah, sure. Sorry, I didn't. I did. Yeah, happy to do that. We didn't establish that ahead of time, but yes. So I don't see any. I can't see anybody's hands raised, and when I'm looking at this, so please feel free to stop me. So yes, question.
Okay, so just on that plane that nearly crashed into a mountain. So it was flying, I assume, in controlled airspace, and air traffic control was responsible for separation. And in addition to GPS, it has also DME and VOR and ADF, and possibly an inertial navigation system and a compass. And if it's on approach, it also has ILS. Anything else? Dead reckoning? I mean, there are lots of systems that commercial aircraft, they are ready for GNSS failure, right? They have to be. And is it, I mean, the controllers are responsible for separation, right? Not the pilots.
So a couple issues there. One, this was in 2019, and GPS, aviation was not nearly as aware of GPS jamming and spoofing as we are now. Not every airport has a instrument approach that's an ILS, a precision approach, especially in mountainous areas. Many aircraft or many airports primarily use GPS-based approaches, and that's the approach that this aircraft was following. And there was not necessarily the radar controller was, I think, 250 miles away because this was Sun Valley, Idaho, so a relatively small airport in the mountains. And again, because it's in the mountains, often the GPS approaches, because they can be much more flexible and designed to accommodate the terrain, are preferred. So the radar controller was far away, small airport, not the airport, I'm sure, did not have radar surveillance of inbound aircraft on its own. Yeah, the pilots were following this GPS approach, and then, of course, their GPS went
okay, but just
off.
unbalanced. But as unbalanced, you would agree, though, that the failure of GNSS in an aircraft is far more typical, right, than spoofing and jamming.
The failure of the equipment? No.
You wouldn't agree that with a billion GNSS devices out there, the failure of the receiver is far more common than this.
So,
do you have any data? Do you have any data that shows how common this is?
So, when you're talking about failure, you seem like you're talking about the electrical failure of the equipment and shorting out and malfunctioning, or
yeah, absolutely, yeah, absolutely. So MTBF, GNSS receivers. How often do they
Oh,
fail vis-a-vis? How often are they spoofed or jammed? Do you have any
oh,
data that shows how often spoofing or jamming occurs?
so there's lots of data collected by Eurocontrol and IATA and other
How do they
organizations.
collect? How do they collect the data? Where can we see
Let
it? I
let
mean, they're
me
not in
let
the
me
aircraft.
yeah, let me go back. So I'll tell
If
you how
if
they
you go
collect it.
to
Let me see. Okay,
gpsjam.org.
here we go. All right. So what you're seeing here, the little red dots, the way that GPS works in aircraft, and the reason we're able to tell that these little red dots are navigational problems is that there's a system called ADS-B aboard airplanes. And my apologies for not providing sufficient background. And what ADS-B does is it uses GPS to determine the location, and it transmits the aircraft's location to other aircraft for collision avoidance and also to ground controllers for air traffic management. And when the aircraft senses that its navigation integrity has been reduced, it includes that information as part of the transmission. And so what you see in the red and the yellow are degrees of reduced navigation integrity that are being reported by airplanes. So
No, but
because
wait. To what extent does it have to what extent does it have to be reduced and for how long? But in any
uh,
event, this shows like the Ukrainian front line. What about in Central Europe in America? I mean, there are many fights every day. How often does this happen?
Can I share my screen as well? Because this is something I track very closely. And
No,
Dana,
but
for the
wait. I'm just trying to understand. Like, is 1 second of bad data enough? 5 seconds? How long? And also, a plane has seven other different navigational systems in parallel with GNSS, and a plane must absolutely be able to survive GNSS failure, right? Now, how big a
the
problem is this really?
Dana, could I share temporarily? I have a bunch of tabs open that I think answers this question, but you just
sure,
stop
let
sharing.
me stop sharing. Yeah, there you go.
I often give full disclosure. I often give a similar pitch to exactly what you're covering, so I have other links as well
Hmm.
related to exact same topics. So, all right, share. See if it's going to let me. Just wait for it to pop up to let me choose. There we go. Just one moment. So the FAA actually put a report out about this finally at the end of last year. One of the frightening things about it that even I was surprised by is it doesn't just interfere with the location as it knows from that one particular system. Apparently, it can also even mess with the avionics. And so if an airplane flies through one of these areas that's under, especially spoofing, and we
No,
can
but
see
wait.
this real
But
time.
how
Oh, hold
often?
on.
What
I'll
about the
answer your
data?
question.
What about
Eh,
the data? Can we see the data? How often does this happen?
Yes, and this is the data. If you go to gpsjam.org, you can see literally every single day we have airplanes being impacted by this pretty much on the entire border between the Russian Federation and NATO. Similarly, in the Middle East, you can also, unfortunately, one of the other things this data may be revealing is where I'm not going to say this is recorded. Um, Sometimes the good guys do this too. If you're doing things like fleet
Oh,
protection or
absolutely. The
critical
U.S. did
assets.
it down during the Venezuela incident. Yeah.
Exactly. I often show my students exactly that. One of the other things is this is not hypothetical. It is alleged that at the end of December, an Azerbaijan airplane was shot down because of Russian electronic warfare. They weren't sure where they were. They then had to try to come back and land again, and many people died. So this is not a theoretical issue. This has already taken life in recent times.
So
And so
there's definite proof that this happened, that this aircraft, okay, with seven different navigational systems, crashed because of GNSS spoofing. That's
that
a
is the most
fact.
likely explanation.
It was
Okay.
shot at by
It was
Russian
shot at
forces
because
because
it
they
wasn't
couldn't
able to
report
land.
its position. They couldn't identify the aircraft.
Exactly. And these are
Yeah.
causing other issues. And then, last, you mentioned a lot of other protocols. The scary thing is all the protocols you're describing, minus maybe the inertial navigation unit, also rely on RF, typically on unencrypted. So 2015, there was the DEF CON on GPS spoofing. 2020, they did the same thing with TCAS, the traffic collision avoidance system. And so there you can actually trip out a plane and get a plane to suddenly hear pull up, pull up, pull up. And again, this is not
Yes,
theoretical.
but a
This
plane has
happened.
but
Hold on,
commercial
let me keep
but
going.
but they
So
have radar altimeters. I mean, could I get you both to accept that commercial airlines have to function and are certified to function even if there is a GNSS failure? Could you
there's a
accept that?
difference there's a difference between what we would hope is the state of the world and reality. But if you
No, no,
look at what's going
I
on today, you have people in highly congested airspace that are relying on certain systems, and because those are being interfered with, it is causing serious problems. So another
okay,
example, and
Can
oh,
I?
hold
this
on.
is the but
So
this is where we don't this is fundamentally where we don't agree. An aircraft never relies on a single system, including GNSS, right? And
it's not.
you must stipulate that this is true, right?
There are. Well, I will stipulate that there are, as a helicopter pilot that flew over 4,000 hours and over 20 for over 20 years, I will agree that there are always multiple systems available, but it's not the aircraft relying on something. It's the pilots and whether or not they rely on everything and how they fly. And the question is, what's the workload on the pilots? How distracted they are? Do they distrust their instruments? I mean,
Exactly.
your family should be
But
able to
wait.
drive a car.
But
Your family should.
I'm an instrument rated pilot as well. Okay.
Okay.
If you find that an instrument is unreliable, what do? You ignore it, right?
That,
And
that's
last, that's not what happened. So this is another example. This is what put me on this space. $400 GPS device could have prevented the crash. And so in this instance, the pilots were doing exactly what you were saying. They relied on barometric pressure to calculate their altitude. The problem, the sensor was wrong. This killed 67 people. So this is not theoretical. This is a
Okay.
real problem we need to
so
look at.
it's
And talking
absolutely the
about
case that there are
and talking
backup
about
systems in
Hello.
but
aviation.
Hello,
but
Yeah.
talking
everyone.
about
Hello, everyone. Can I request that we go back to the original presentation that we were here for?
Yes, I think that's a good
Please?
idea.
Awesome. Thank you so much. Feel free to take this to a different forum, but we're all here to learn something. Thank you.
Okay. And yeah, so there are lots of reports about the extent of GPS interference and the impact on pilots and so forth. And it's absolutely the case that it should be that everything is just fine. And generally, everything is just fine when GPS is interfered with. But it's not always just fine. And it's the not always that is the real concern, I think. So I'm trying to advance my slides now. Oh, there we go. Okay, so I'm going to get back to where we were. Um, so we're talking about, we're basically talking about reduced safety margins. And, have we had a 9/11 event yet with GPS jamming and spoofing? No. But we have had precursor events, just as we did with 9/11, with 142 airliners hijacked before 9/11. Did we take sufficient action to prevent the really bad thing from happening in the 9/11 case with aircraft hijacking? I would offer not. Are we in the similar situation with GPS interference? We may well be. Okay, so anyway, 2016, we had and what we're showing here are admittedly potential, a lot of precursor events. In this previous incident, the United States was humiliated. Eh, President Obama was humiliated. How bad is that? As the world's leading power, it could be pretty bad. So we have seen bad things happen. And I think the question is, to what level are we willing to accept additional bad things happening or worse things happening? Oh, so anyway, as we step through history, 2016, Pokemon Go really solidified for the popular the popular idea of how important location is and it could be spoofed. 2016, we also saw uh, very concentrated spoofing in Moscow. What the folks trying to go to the airport with a Lyft or an Uber in Moscow found out that their devices were reporting they were already at the airport, and so they couldn't get one to come and get them. The idea is that the Russians had installed spoofing equipment in the vicinity of the Kremlins to protect their VIPs from uh, drone attacks because Generally, at the time, most drones were programmed at the factory to avoid airports. And so if you made an area look like it was at an airport, electronically anyway, then drones would either land or fly away from there. So we were seeing that in Moscow in 2016 and 2017. We started seeing it in the Black Sea. This is one of the first reports where a ship is in the middle of the Black Sea, but it is reporting that it is actually ashore at a local airport. And if you can look real closely there, you can see that oh, here we go. You can see that the reported antenna height is 39 meters below the surface of the water. So uh, certainly a real good indication of GPS spoofing. After that particular incident, we started to poke around in vessel tracks in the Black Sea and found any number of really, really large vessels reporting that they were spiking speeds of up to 60 knots, which is just physically impossible. So clearly, a lot of interference and spoofing with GPS there. As you can see, we worked with one of our partners, and they helped us identify a bunch of ships that were moored actually on runways. A couple of years later, the organization C4ADS, one of our partner nonprofits, did a more detailed study and found that the Russians have these portable wide area spoofing devices that would transport pretty much any GPS user within the vicinity to an airport. And that when Russian VIPs would go on vacation to their dakas, these devices would come with them, and you'd see all kinds of folks reporting that they were at airports when, of course, there's no way they could be. And this is the report. You can look it up online if you want to get more information about that. We also saw the Institute of Navigation conference in 2017, a unsecured test device transmitting signals that caused a number of cell phones to essentially be bricked and have to be reset. 2018 saw a report on how you can spoof all of the global navigation satellite systems at once. And for background, I failed to say before, there's GPS, which is the first one. Similar systems are GLONASS, which is the Russian system, Galileo, the European system, and then the newest and most capable is Beidou. But they all operate in the same frequency band. They're all very faint signals, so it's very easy to jam all of them at once. And as this study showed, you can spoof them all at the same time as well. And then next, after that, we saw a paper where some students had determined not only can you spoof all of the devices, but you can also send a false map to the receiver so that when the person looks out the windshield or out of the aircraft or ship, it kind of looks like where the GPS says they ought to be. So it's even easier to lure somebody down the path. We saw another incident in 2019. You may recall when this drone was shot down. President Trump was all up in arms, was going to retaliate, and then all of a sudden back down. The community is fairly certain that what happened was the Pentagon thought the drone was in the middle of the strait there in international airspace, but it has been spoofed over into Iranian airspace. We've seen this with ships being seized as well. Not sure I have a slide of that, but ships being spoofed into Iranian waters and being seized in retaliation of something else. The next year, we saw advent of a new kind of spoofing, where the positions manifest as being pretty much in a circle, counter-rotating about 20 knots. The idea behind this, we think, is accidental software feature or hardware feature of a new spoofing device that we've seen. And as you can see here, we have seen all kinds of other interference, both good guys and bad guys, that have manifest. This particular one here is evidenced from on the left from a fitness application that crowdsources all of its information online. It's in the vicinity of both of these are in the vicinity of the Iranian military staff college in Tehran. And so there's obviously some kind of a spoofing device there. Uh, this is information from SkyTruth, which is an environmental uh, charity, shows that ships that have either entered or spoofed their own locations and ended up reporting that they are on the opposite side of the Earth, off Point Reyes, California, and uh, flying in circles. So the bottom line is that, as with any technology evolution and progression, what we have seen is that it's gone from being the ability of nation states down to something a reasonably competent hacker or hobbyist can do. The cost is gone down, and the capability of the equipment and the ease of use has gone up. So uh, here's another example of things that we've seen in recent years with the Ever Given going into the Suez Canal and getting stuck sideways was not a feature, but the image on the upper right-hand corner is the plot of the Ever Given before it entered the Suez Canal. So you can see that professionalism was not exactly one of the strong suits of the crew there. Um, this is particular instance is interesting because this was not radio frequency interference, but it was interference with the data before it actually entered the database to be displayed on maritime traffic. Good signals from the satellites, a good report from the Navy ship in terms of the AIS, which is the maritime counterpart for the ADS-B. It tells other ships where they are and tells ship traffic management ashore where they are and facilitates traffic management. So all of that was good. No radio frequency interference with either one of those. But as the data, or before the data entered into the database and was displayed, it was spoofed and taken off course there. It was shown to be someplace that it wasn't. More another display to show you exactly what an individual track looks like in the Baltic when Kaliningrad is active and somebody gets spoofed. And then some of the here's some of the nefarious uses that we've seen and been reported. You may be particularly interested in Guy Fieri's challenge. It was apparently a GPS spoofing device that caused his cargo of tequila to go missing. Um, and of course, with the Russian shadow fleet has long been known for spoofing their locations, both with AIS and other GPS-enabled devices uh, to conceal their activities. And the gentleman made a really good point that both in aviation and in maritime, interference with GPS doesn't just affect navigation, it affects a whole suite of other applications and devices. For example, digital selective calling uses timing from GPS. The divert information and electronic flight manual bags on cockpits use GPS. Uh, Radio frequency spectrum division and allocation uses GPS timing, so it has the potential to cascade through an entire platform's suite of electronics. There are a number of places where you can see how this is happening. And, in the ultimate, it's not just cargoes of tequila that are at risk, but, it's possible even for entire cargo ships to be spoofed and taken someplace over the course of a journey and end up where they really don't want to be. So what do we do? Well, this is really one of those wicked problems. There's very little that can be done to create counter incentives to jamming and spoofing. The rewards are too great, and the activity itself is just too easy to do. And it's very difficult to to detect in time to intervene and terminate it if it's in your own territory, and if it's another nation states that's doing it, it's short of armed combat, it's difficult to persuade them to stop. We advocate for a comprehensive approach that we call protect, toughen, and augment, which has actually been developed by the President's Advisory Board. You certainly need to be able to, especially in your own country, detect when interference is extent and then have the regimes and the capability to take enforcement action against it and stop it. We also need to have improved equipment that includes anti-jam and anti-spoof hardware and software. That's much more expensive than the $3 chip that's in your cell phone, but for certain applications, it's appropriate. And in many instances, it's not there for a number of reasons. Cost is one. Just standardization and integration is another. For example, in the aviation case, a controlled pattern reception antenna, excuse me, would really prevent a lot of interference with GPS signals, but they've only recently been approved for export outside the United States, and it will take years to incorporate those into aircraft systems with all the approvals and safety requirements that are done. So there's a number of challenges to that in addition to just the cost. And then most importantly, we think it's important for every nation to have a resilient PNT architecture. We suggest that includes a combination of signals from space, terrestrial broadcast, and timing signals over fiber, so that any one adverse vector is unable to interfere with all the sources of your position, navigation, and timing information. So this is just a screenshot of all the members of the Resilient Navigation and Timing Foundation. We are always happy to have more. There we go. Holly must have added that in there. And now I'm happy to move to the most important part of the presentation, which is your questions, because I think folks learn more from that than from any blathering former federal bureaucrat does. So I'm happy to engage in whatever discussion you would like.
Wonderful. Thank you, Dana. Okay, let's open the floor for questions.
I have some, but Philip, you raised your hand. I know you were asking in the chat about two-way comms. Do you want to go first and then?
Yeah, let's go with Philip first, and then we go with the chat. Yeah.
Okay.
Yeah, I have a few questions in the chat. I'll pick one. Is two-way communication the only option to mitigate the jamming and spoofing? And can you talk about how authentication could work with a one-way system? Like I know Zona Space Systems claims to have some sort of authentication there. Is two-way communication required to defend against jamming and spoofing?
So caveat and disclaimer, I'm not a technologist, policy guy, a recovering helicopter pilot. So, small words, short sentences. But the short answer is no, two-way communication is not required. It can help. So, for example, you used to be, up until the 20th, you can go into your Starlink receiver and find your location based on two-way communication between your receiver and the Starlink satellites, right? And so if you're in a GPS denied environment, you can often, by going into the depths of your receiver, figure out where you are. Now, that feature is going away on the 20th of May, probably because they're going to start charging for it. But no, GPS, all GNSS, other systems like ELRAN are basically a receive only, and you can determine your location from there. You just need enough signals from enough different directions to be able to do the math. Other questions?
Thanks. Go ahead, David.
Oh, thank you so much. So first, I can't thank you enough for your service to our country, and even more so, the topic you talked about is literally the topic front of mind for me as well. I've been putting students on this a lot, or even looking at doing capturing raw waveforms, and then looking at if we could do more advanced analytics, AI computation, rather than, as you mentioned, trying to do this on this little $3 chip for some of the most sensitive systems. And where I first got into this was in trading. We synchronize our data centers. And this is the lifeblood of everything we do is time series. If we don't know what time it is, this is a big concern. And so originally it was about just jamming, but now spoofing. One of the things I wanted to show you, and this may be just one thing that even your organization could help with that's concerning, is just how easy this is to do and not even intentionally. I'm going to show you what's essentially a homework assignment or lab proposed by one of the vendors. If I can get this up. Find the right window. Apologies for the delay. Here we go. So separately, I was pulling it up, beat me to it. Starlink announced they're getting rid of that feature. But
Right.
this is from MATLAB. So I love MATLAB, and they have an amazing toolkit. You can actually generate the synthetic waveforms necessary. Now, I don't want to use the term spoof for this because this is completely legitimate. Any of us who are building, testing, evaluating GNSS receivers, one of the problems in this space, no pun intended, is it's very hard to test because the environment's always changing. So you need signal generators.
Right.
But this is actually an example that uses this device. This is about a $200 device designed for every student to have one. They can plug it into their laptop, and it's a software-defined radio based on, I think, a Xilinx Zig platform with an ADC DAC from Analog, the 8963 something, if I forget the exact model number. This is the part that worries me, though. In the homework
Mhm.
assignment, they're actually showing the antennas.
Right.
Now, I'm directly across from UIC. If a student were to do this, and we're right near Midway Airport, this is a big concern. So I want to reach out to them and say this should be a coax cable. But the barrier to entry to do this now, you can get variants of this device from Alibaba, and they're now sometimes in the sub $100 range.
Yeah.
So
Yeah.
we are not talking about nation state, and they have simulators that can do this for different protocols.
Right.
And then I know Lassa was coming on and saying, well, there's other systems. A lot of those other systems are also RF based, whether
Right.
it's the RF altimeters, the guiding for landing. Another one that happened 5 years later was they demonstrations of spoofing TCOS.
Right.
One of the questions I had for you that I do find a little disturbing, and I want to say this very delicately.
Mhm.
I understand why there needs the good guys, do your good people need the ability to do this. I do get concerned sometimes, though. I remember years ago there would be NOTAM sent out, notice to airmen, where the U.S. Navy would announce they were going to be GNSS jamming and or spoofing the entire eastern seaboard, including where all our data centers are. That
Yeah.
is not something our own government should be actively doing. And so if we just look over the last several months, I'll say this very subtly, but if you look in New Mexico, and I'm not going to say it for the transcript, and please don't, but we can see what's at the center of this wave of interference. Again, I get why we need to do this. I really wish we weren't doing this in the middle of the continental United States over major air pathways. And then you
Right.
can see,
Well,
for
yeah.
example, every day these cartels and then these other
Right.
spaces. There's also a concern of, again, I don't want to mention this for the transcript, but are we also giving away more information than we realize from a tactical point of view? But one of the questions for you is, to what extent should the U.S. government be doing this and be doing this on U.S. soil? I can understand if we did it out in the middle of the oceans, like where we have test ranges for ICBMs, but this has always concerned me. And then this is coming out more and more. There was even the case that right after that horrific crash in DC that killed, I think, 67 people, pilots kept landing at Reagan and they were getting TCAS, the traffic collision avoidance systems, that literally tell the pilot, pull up, pull up, pull up. And they kept landing. I also curious if you ever got an answer on this. There were some reports from Senator Cruz that this was the U.S. government doing it. There were different variants of it was the Secret Service plus Navy, Secret Service plus Army. They later denied it or somewhat. But one, what do you think about the U.S. government and other allied governments doing this on their own soil at scale, not in an isolated region? Uh, Yeah,
Yeah,
I'm
so
curious your thoughts because this makes me
yeah,
very
so
uncomfortable.
so there are valid reasons for government agencies to interfere with GPS signals. Now, how broadly they need to do that is another question. Certainly at Las Cruces and the test ranges in New Mexico, there are military exercises and equipment tests that need to be done. As you say, those are NOTAMed. In the DC area, and in fact, for World Economic Forum and other events, you will see NOTAMs out saying GPS and other GNSS is not going to be reliable because we're going to protect the VIPs. And, part of the motorcade is the van with all the antennas on it and
Yeah.
uh, interfering with all kinds of signals there. So there are valid reasons to it. But to really answer your question, let me go orthogonal for a second and suggest that the U.S. government has gotten us addicted to GPS and positioning, navigation, and timing for free, and which is actually generally on whole has been a really good thing. It's been the technology that has boosted productivity and gotten us more efficiency in our economy than anything else in the last 50 years. I mean, all kinds of economic and human benefits from GPS and free, highly precise PNT. Doesn't it also have a responsibility to give us an alternative for when it needs to take that system away, so that that system is taken away from us by an adversary that is jamming or spoofing from space, for example, which we know is absolutely possible, and we have some evidence that it's been done. So, so I would suggest that one of the longer term solutions, and it doesn't have to be that longer term, is for the government to institute more resilient PNT architecture for the nation that includes GPS as the cornerstone. It also includes terrestrial broadcast and an extensive fiber timing system so that we have that resilient PNT triad, and we don't need to worry so much about these kinds of interference events completely taking the service away from us.
You nailed it exactly. And this was a very specific question I was about to ask, and you already touched on it. How can we in industry get direct fiber access to the outputs of both the atomic clocks at NIST and wherever it's either the USNO now and or Space Force, so that we don't have to then bother getting it from space if we already have enormous dark fiber at these extremely important data centers?
I have to pay for it. NIST has a program by executive order where they will sell you a direct connect
Hmm.
to time, and the that's been in place since 2019, I think. Only one company that I know of has taken them up on it, and they couldn't make an economic go of it because they couldn't sell forward the direct connection to NIST time. You
And
won't
is,
be able to
is
connect to USNO, but NIST and USNO are synced, and so yeah.
And is that something they should be selling or just giving it away? For decades, and this has been broadcasting over the air on some of the channels like 10 megahertz and other multiples of
Right.
five.
Well,
Why not
yeah.
just give it?
It's just a matter of well, it's a policy decision. They say that it's a cost recovery thing that they're doing. That they're not really making any money because they're the government. They're just recovering the cost of providing, connecting you and ensuring the service works.
Do you think they would provide that for free to academics and research networks? We have things like Internet 2 and all this other dark fiber connecting various universities.
I don't know. You might try some of the national labs because the national labs have pretty darn good suites of atomic clocks as well.
Jerk.
Sorry, I apologize. I didn't realize I normally put that on silent. So,
No worries.
yeah. Although I do have to pop off because I have an interview at 3 o'clock. So,
Well, thank you so much for coming here, for doing what you're doing, and for focusing on this extremely important issue. You really touched on something that's near and dear to, I think, a lot of people on this call. So we can't thank you
well,
enough for what you're doing.
well, my pleasure. And we're happy to have your nonprofit be a free member of our nonprofit if you like. And we have an extensive library Our blog is searchable and has all kinds of information. And if anybody wants reports on the number of spoofing and jamming incidents from UN bodies or Eurocontrol or anything else, then that's available in our blog, or we can send that along too. So,
Yeah, for
Perfect. I'll
sure.
follow up offline to connect, but
Yeah.
thank you so much. I really appreciate what you're doing.
pleasure. Thank you very
Yeah,
much,
we
everybody.
probably can join. Yeah, like definitely because we're also nonprofit. Yeah. All right. Thank you very much.
All right. Nice
All
seeing you.
right. See you, everyone.
Bye-bye.
Bye bye.